Hey everybody, we're going to work on triangle properties lesson number 2 today. We're going to talk about perpendicular bisectors and we're going to talk about angle bisectors. We are going to practice drawing them a whole lot in lesson number 3, and you end up getting some pretty incredible drawings. They end up looking kind of Da Vinci-like. You're going to discover some really cool things. Today we just sort of have to get through the nuts and bolts of the whole deal. Starting with a perpendicular bisector, and it's probably not a big surprise to anyone that perpendicular bisectors must be perpendicular and they must be bisecting. So a perpendicular bisector basically takes a segment and it chops it in half, and it is also perpendicular to the segment. So we're going to get into some pictures of that later. Right now, we're just going to jump into some theorems that go with it. And there is a lot of writing. If I go too fast, feel free to just pause the video. So we're going to start with theorem 5.2, and it makes pretty good sense that if we are going to have a theorem about perpendicular bisectors, we should call it the perpendicular bisector theorem. Gee, how creative. All right, so that theorem says if a point is on the perpendicular bisector of a segment, then all right, let's put this here. Then it is equidistant, so that means same distance from the endpoints of the segment. All right, now I think it's very important to actually see a picture of this before we move on. So I want to put this here. If this, then this. So let me show you what I mean. If you have a point that is on the perpendicular bisector of a segment, so let's do this in red here. I'm talking about this point right here. If you have a point on the perpendicular bisector of a segment, and you can see that it's a perpendicular bisector because it is perpendicular, and bisecting means it chopped it right in half, so we ended up with 2 equal pieces. If that happens, then this point right here that we're talking about is going to be equidistant, so it's going to be the same distance from the endpoints of the segment. Okay, so we're going to do that on the then picture. If we have a point that's on the perpendicular bisector of a segment, then that means if you were to take the distance from here to here, it would be the same distance. And what's cool about that is that it works for any point along the perpendicular bisector. So I could have picked this point right here. That point is going to be equidistant from the endpoints of the segment. So if I drew a line here, and I drew a line here, a line segment here and here, it would be the same distance away from both, which means these 2 lines would be congruent. These 2 sides of the triangle would be congruent. So it works for any point along the perpendicular bisector. It could have been a point way up here. It wouldn't have mattered. It still would have been equidistant. So it doesn't matter how far up or how far down you go. Don't do this on your paper. I'm just giving you an idea of what's going on. All right. Now, as you are probably aware, it seems like probably half the time in this chapter we do this, or in previous chapters we've done this. We have the converse. Now, the converse being true just means we could take the if-then part and we could go backwards. So now we can say if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So essentially what we're doing now is we are taking our drawings from before and we're just kind of throwing them in reverse. So now we're saying if this is true, then it's on the perpendicular bisector. So let me show you what that would look like here. If you have a point, so now we're talking about the green point. If you have a point and that point is equidistant from the endpoints of a segment, as in it's the same distance here as it is here. If that is true, then that means that point is on the perpendicular bisector of the segment, which means you could draw in a line perpendicular to that opposite side right there. Okay, so let's make it a right angle right there, good. And then it's bisecting, which means we're going to have to do that. And we're going to have to do that. Bisecting means it breaks it up into two equal pieces. In the last chapter, we used the word bisecting a whole lot with angles. Now we're using it with sides. Of course, I guess that's a good segue because there are some pretty cool rules that also apply to angles, so we should probably knock them out too. So, yeah, I guess we'll just lead right into it. I mean, we might as well keep on rolling. Angle bisectors are a little different because they bisect an angle instead of a segment. Okay, so again, in the last chapter, we did a lot of proofs that involved statements that said this segment bisects this angle. So we have some experience with this one. So let's see where this takes us. If we're going to have a theorem about angle bisectors, we should probably call it the angle bisector theorem. Genius. Boy, we are just feeling good here. And I'm going to have to, when I get done with this, I'll scroll down. You can see what's going on. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. All right, let me show you what that looks like here. If a point is on the perpendicular, or if a point is on the bisector of an angle, I got going saying perpendicular a bunch there. So notice how we have a line here, and it is chopping an angle directly in half. If you look here, we have this angle and this angle are marked the same. So this line right here is an angle bisector, and I know it's an angle bisector because it chopped this angle, this big angle, into two equal pieces. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle, which means this point is going to be the same distance from here to here as it is from here to here. Here, let me draw it again here on the then part. So again, if we have a point and it is on the angle bisector, so if that is true, then that means that point is equidistant from the sides. That means this distance and this distance will be the same. Now, on this then picture, what I want you to do, I want you to mark these two as congruent because, again, it said the point is equidistant from the sides of the angle. And also, while you're at it, what's interesting here is the shortest distance that you can draw between that point and that side actually makes a right angle. That is the fastest way to get from here to here. Well, let me kind of show you what I mean. What if we wanted to draw a line from the point over here? Well, that's a really long way to go, right? That's too far. Or what about here? That's still too far. That's still too far. And if I wanted to go over here and meet it up high, that would be too far. The shortest distance that you can make is actually the distance that makes an exact right angle to the side. That's just a little something I wanted to add into the conversation here. All right. And then it's not going to be a terribly big surprise that we are going to have a converse theorem as well. Now, the angle bisector converse theorem is going to have the if and then switched around. If a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. All right, so let me show you what that would look like here. So let's say we have a point, and I'll just make this point red again, that's fine. And I know that it is the same distance away from one side as it is the other side. So the distance from here to here and the distance from here to here are the same. If that is true, then that means the point is on the angle bisector, which means I could draw a line through the angle itself, and that line would be the angle bisector, which means this piece and this piece would be the same measure. Okay, so that means essentially what we're saying is this rule works both ways. So if I am the same distance away from each of the two sides of an angle, then that means I am on the angle bisector. Now, angle bisectors are a little bit tricky to work with because a lot of us don't carry protractors around, or they break in our backpacks or whatever. So the drawing is really just a sketch. I did not actually measure out each one, but I think you can pretty much see the idea of where we're coming from. All right. I hope this helps build a foundation for the future lessons, and I will see you next time.